All right, let's just review really quick what we did last Thursday because that was forever ago. So last Thursday we were talking about what are angular velocity in radians per second, and then we always went to linear velocity. So most of the time, most of these problems are going to give you some sort of revolutions and how long it takes for it to revolve. So in this case, they said that it revolved 2,500 revolutions per minute. So 2,500 revolutions per minute is technically angular velocity, but it's not an angular velocity that we can use. We need to convert that to radians so that we can then multiply by the radius to get our linear velocity. So that's the whole reason why we have to put in radians. So to put in radians, we basically just had to multiply by 2 pi. So we get our revolutions, multiply by 2 pi, and that gets us our angular velocity in radians. Now the next thing we needed to do on this one was to change this minutes to seconds. So we just had to do a little balancing where we had minutes on top of minutes, and so we had radians per second. Then to put it as linear velocity, all you have to do is multiply by the radius. And we said if the lawnmower blade was 22 inches, its radius was 11 inches. So we just took 11 inches, multiplied it by our angular velocity, and we now have our linear velocity. The only thing is it wanted it in miles per hour. That's why we went one step further, and we converted it to miles per hour. I wanted inch in miles, so I put inch on the bottom down here, and I put feet up there, and I said 1 foot equals 12 inches. Now to get from feet to miles, I put feet down here, miles up here, and I said there was 5,280 feet per 1 mile. With canceling out, we got miles. And we did the same thing for seconds to get those up to hours. And we got 163.6 miles per hour. All right, just as a refresher, we're going to do one problem together with the Ferris wheel. And then I'm going to let you just work on the homework. All right, the Ferris wheel problem says, a Ferris wheel with a radius of 50 feet makes 1.5 revolutions per minute. The first thing it says is find the angular velocity of the Ferris wheel in radians per second. It says radians because, once again, in order to put it in linear velocity, we need angular in radians first. So we're going to go ahead and find our angular velocity. Which is basically how many revolutions we have over how much time is given to us. In this case, they said it's 1.5 revolutions per minute. So our angular velocity right now is 1.5 revolutions per 1 minute. Now all we have to do is put an angular, and we have to put in radians, so now we have it in angular velocity in our radians. In order to do that, you can think about it as we're just multiplying by 2 pi. But another way to put it is, since there's 2 pi radians per 1 revolution, that says revolution, our revolutions would then cancel out. But in short, I'm just multiplying by 2 pi. Every time I'm just multiplying by 2 pi. So that's just going to give me 3 pi radians per 1 minute. All right, then it says find the linear velocity of the Ferris wheel. So that's my radians per minute angular. This is putting in linear velocity. Linear velocity, all we're adding in is the radius. So all we've really added in is 2 pi up here, and then we add in the radius down here. So our velocity is going to equal our radius. Let's actually put our radius. Our radius is going to be 50 feet. It does say 50 feet is our radius. Make sure you're not looking at diameter. If you said 50 feet diameter, you have to divide it by 2 to get 25. But in this case, it does say it's 50 feet. That is our radius. And our angular velocity is 3 pi radians per 1 minute. Now, just a recap of why we put it in radians. Since this is 1 radius, it kind of happens subtly. I don't usually write this out. I just put it in our notes. But we can remember that this is a radius, so our radians and radius cancel out. I don't usually put that. It just turns into kind of radius and radians.
When it says it's time in radians per second,
Oh, I did not do that, did I?
But would that affect the answer in B?
It would not affect the answer in B, but it would affect the answer in A. I completely went right past that. Thank you for pointing that out. It does say that we're supposed to put in radians per second. But it totally does not change the next one. So I can leave this as is. I can leave this as is because it already wants it per minute. And I already have it per minute. So sometimes I miss this one because I'm looking at the minute one down here. But I should have converted that to seconds, just like you said. So let's go ahead and convert that to seconds. Well, to convert it to seconds, I just need to have minutes over seconds. So my minutes can cancel out. And I can say 1 minute equals 60 seconds, which is just going to be 3 pi radians over 60 seconds. In this case, I'd probably round, and I think I rounded on here. I said that would just be about 0.16 radians per second. So now I completed that first part. The second part, I'm just going to leave alone. Because if we look at what it needs to be in, it needs to be in per minute. So why not just take the one that's already in minutes versus the one in seconds and converting it back to minutes? So it's just going to be easier if I use this one because we're already doing per minute. So let's just use that one here. It also leaves me so I don't have to do any conversion. So I would just approximate that right there. We just do 50 times 3 pi. And what does that come out to about? If I do 50 feet times, or 50 times 3 pi, what does that come out to about? Right? About 150? It'd be 150 pi. We just have to multiply it by pi. Yeah. Oh, anyone? Yeah. 471.24. Sure. 471.24 feet per minute. Does everyone understand why I did not take this one, but instead used this one? Does everyone understand why I did that? Do you think you'd be wrong if you take this one? No, you just gotta make sure you convert it to minutes at the end. All right, it makes an extra step for you. So I would just recognize that I already had the minutes. Let's go ahead and use that. All right, any questions of what we did? Your big thing is basically multiplying by 2 pi and multiplying by your radius and making sure your units match up with what your answers are. Okay, then the rest of the time is yours to work. As a quick reminder, our test got moved back to Tuesday, so if you're following your sheet, it isn't next Friday, it is that Tuesday after. Yeah.